Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is again another video. Okay, I want to discuss on Sidesway Frame analysis. Okay, Sidesway Frame analysis. So I always repeat about the concept of principle of superposition, because in analyzing frame with Sidesway, we need to understand the concept. Okay, we need to understand the concept, what is actually we analyze in table number 1, what is actually we analyze in table number 2. Okay, we have to have the idea why we need to have two table. We have to have the idea why in the second table we need to analyze r prime, not r prime which is occur due to Sidesway, and why it is delta prime, and we need to understand all these principles so that we know what actually we do in analyzing frame with Sidesway. Okay, so we apply the principle of superposition, and this is not the only time, this is not the first time we analyze structures using principle of superposition, because principle of superposition is actually one of the principle that is applied in engineering, in civil engineering. Okay, so we apply principle of superposition in moment distribution method because in Sidesway frame analysis, we have combination of external loading and delta, because we need to understand first that FEM basically, okay, we analyze external loading. Okay, basically we analyze external loading. We can calculate FEM value due to external loading, and FEM is always behavior. FEM is behavior. Okay, the moment behavior. Okay, towards the given loading. Okay, the given loading. But we need to know as well that fixed end moment is not only for external loading. Okay, so not only for external loading, it is actually beside external loading, we can also analyze or calculate fixed end moment whenever there is a delta due to settlement. Due to settlement means it is a vertical displacement whenever the element is horizontal. Beam is horizontal element, and the delta must be perpendicular. So the settlement is in vertical direction and it is perpendicular to the beam. So when we analyze frame, we refer to the column. Okay, we refer to the column. So column is a vertical member. Column is a vertical element in the structure, and perpendicular to the column to vertical is horizontal. So Sidesway referring to the displacement in horizontal direction. Sidesway referring to displacement in horizontal direction. Okay, so we have to, but before that we have to know, as a student you have to know how to differentiate between Sidesway frame and non-Sidesway frame, because non-Sidesway frame has two conditions. Number one, it must be symmetry. If the frame is symmetry due to loading and due to geometry, so the frame is non-sway frame. But there is a case where the frame is unsymmetry but it is properly restrained means there is a reaction in horizontal due to support. So there is a wall. It is just like wall. Okay, that will constrain. Will block the movement, the horizontal movement. So in this case, it is called as properly restrained. Properly restrained means there is a restraining force. Properly restrained means there is a restraining force which comes from support. which come from support. It can be fixed, it can be pin, it can be roller. As long as the support give the horizontal reaction, okay, towards the support. Okay, towards the support. So we need to understand this principle because in Sidesway frame analysis there is a combination between external forces, because whenever frame is not symmetry, maybe the column is not symmetry, column AB and column CD has different length, for example. Now it is unsymmetry. So when it is unsymmetry, it is now called as Sidesway frame. But if we want to remove frame from Sidesway, what should we do? So we should change the frame to properly restrained frame. So what should we do? We should put an artificial support at C so that the frame cannot move horizontally. That is why we have to understand these two conditions for non-sway frame. It must be symmetry, it must be properly restrained. Okay, it must be properly restrained. So to analyze frame with Sidesway, we have to have four procedure. Okay, for procedure. Number one, we, of course, in moment distribution method, we need to start with calculating the stiffness factor for each element or each member using formula. It is 3EI, K is equivalent to 3EI over L for N pin or roller, and K is equivalent to 4EI over L for N fixed or internal support or rigid joint. Okay, that is the formula for K. And why we need to calculate K? Because we need to calculate distribution factor. Distribution factor is member stiffness divided by joint stiffness. We have to calculate distribution factor. And we must know that distribution factor for N fixed is 0 and distribution factor for N pin is equivalent to 1. And another one is distribution factor for each joint is equivalent to 1. Okay, is equivalent to 1 except N fixed. Only N fixed, the value is equivalent to 0. Okay, so this distribution factor we use in order to distribute moment. So we will actually use distribution factor in table number 1 and in table number 2. Okay, table number 1 and table number 2. Okay, now we move to the second procedure where this part is called as non-sway frame analysis. So in this non-sway frame analysis, actually the question given is Sidesway frame. So how we get this? So to become this non-sway frame, we have to apply principle of superposition, where the principle of superposition will divide the frame into two systems. One is called as non-sway frame, and another one is called as Sidesway frame. So in non-sway frame, we need to remove delta from the system so that we can calculate FEM using formula for loading. Okay, because we have to remember that FEM is divided into two. One is due to external loading and one is due to delta. FEM itself has two. Okay, we have to consider these two conditions. So whenever we want to analyze frame that is actually in actual condition has combination of external loading and delta, so we have to apply principle of superposition in order to divide between external loading and delta. We have to divide into two. Because in frame analysis, we know the external loading. Because external loading is given in question. Point load. When we have to analyze frame, using moment distribution method, for example, the frame is subjected to point load at B. The point load is given value. We can see that in the question. The frame is subjected to UDL along member BC. The W value is given in the question. So we know the external loading value. So when we know the value, for example, that W is actually subjected along the member. So we have to distribute to the joint. Using fixed end moment. So we can calculate as usual using formula. But what happened to Sidesway is we do not know the delta value. And we don't need to calculate the delta value. The delta is unknown. So when delta is unknown, but external loading is known, that is why we cannot calculate it in one table. We cannot do that. We can combine FEM due to external loading and FEM due to delta whenever delta is known value. For example, the support settlement. Support settlement is given in the question. So, okay, we will take break for a while. Okay, Assalamualaikum. So, okay, continue again. Okay, before we take break just now. So I was talking about FEM due to FEM, which we can have two condition. One is FEM due to external loading. One is FEM due to delta. Okay, so for beam analysis, whenever we analyze beam with support settlement is given in the question. When settlement is given in the question, we know the delta value. So we can just substitute the delta into the formula, then we can combine FEM as one. We can calculate FEM due to external loading, and we can also calculate FEM due to delta, due to settlement, and we can combine the FEM and we will put into one table, into the distribution table, so we can continue to distribute moment and find the final the member and moment for beam, for example. But in frame with sidesway, we cannot combine the FEM. We cannot combine the FEM because the delta is unknown. The sidesway is unknown. And the delta due to sidesway is unknown, and we do not need to calculate the delta. So that is why whenever we have frame analysis with sidesway, so we have FEM that we can calculate the value due to external loading, and we can also need to assume FEM due to unknown delta value, unknown sidesway, unknown delta value. So that is the idea why we have to have two distribution table. So we must have table number 1, which is called as non-sway frame analysis. Table 1 is non-sway frame analysis. Okay, why we have non-sway frame analysis? Because we have removed the delta. And we have table number 2 called sidesway frame analysis. So in table number 2, we will only calculate, consider FEM due to delta only, due to sidesway only. There's no external loading that will give the value of FEM. So we have to separate FEM due to external loading and FEM due to delta. That is the idea why we have to have two tables. One is called as non-sidesway frame, another one is called as sidesway frame. Two tables. So in the first table, non-sidesway frame, the idea why from original sidesway frame we have now non-sidesway frame or non-sway frame. It is because we remove the delta. Okay, we remove sidesway or we remove delta by putting an artificial support to block the movement. Means that we have to understand the concept of properly restrained, because from sidesway frame, original sidesway frame, when we put artificial support at C, the frame will become properly restrained, and properly restrained has no delta. Properly restrained is non-sway frame. Properly restrained has no delta. So FEM in non-sway frame, table number 1, will be only calculating due to external load only. Okay, external load. So we focus this non-sidesway frame. Okay, when non-sidesway frame, as shown in the screen, we have step number 2 that will focus on table number 1. Table number 1. Okay, non-sidesway frame is table number 1. In table number 1, we have to calculate FEM due to external loading only. For example, we have frame like this. Okay, there's UDL point load like this. This is original. This is original. But to be non-sidesway frame, we have to put an artificial support. So it will become like this. So this is the frame that we analyze in non-sway frame. Non-sway frame. Table number 1. Table number 1. This is the frame. This is the frame. So in this frame, we need to analyze, we need to calculate as the fixed end moment at along member BC. Okay, there's no fixed end moment for AB and for CD. Okay, as shown in the figure. So we need to calculate FEM for member BC, along member BC, and we will use this FEM as the first member and moment in the table, because in the table we distribute moment, and the moment that we distribute come from member and moment. However, under distribution process, the moment that we distribute is not member and moment, but we distribute joint moment. So all this, okay, we do in the table. It is under 2B. And in the table, after we will distribute moment, and whenever the moment in the table reaches 0 value, we can distribute moment, and then we total the moment start from the first member and moment in the table. The first member and moment in the table is FEM. So we start from FEM until the last distribution. In the table, we calculate member and moment start from the first member and moment in the table, which is FEM, until the last distribution. So we calculate, and then we find the total and moment. So we have 6 member and moment. One member has 2 end. That is why for frame ABCD, AB 1 member, BC another member, CD another member. So there are 3 members. So 3 members means there are 6 member and moment. So we calculate from the table the M value. We calculate from the table. So after that, from the table, the end moment that we calculated is actually the internal moment. So this internal moment will be used to calculate the restraining force R. We will use the internal moment from table 1 to calculate the value of R. So the value of R will be determined using shear equation. Okay, using shear equation. Is shear equation and column analysis. Okay, the R value will be determined using shear equation and column analysis. Means that we need to analyze column AB, we need to analyze column CD separately. Because in shear analysis, what is shear analysis? Shear analysis is actually total Fx is equal to 0. So we have to write one equation, okay, in order to calculate R value. And in this equation, in this shear equation, there will be unknown. Based on the diagram, there will be unknown AX and DX. Unknown AX and unknown DX. Okay, unknown AX and unknown DX. So column analysis actually refers to how we analyze column AB and column CD to determine AX and DX value. Because once AX and DX is determined, then we will substitute into the shear equation, then we can get the R value. So that is actually all about the analysis that is under procedure number 2, table number 1, non-sway frame analysis. Okay, and then we have to move to procedure number 3, table number 2. Procedure number 3, table number 2. Under procedure number 3, it is called as Sidesway Frame Analysis. Sidesway Frame Analysis. So how is it, okay, look like? So this is actually frame, sidesway frame without need to considering FEM due to external load. Okay, means that we need to consider only delta, need to consider only sidesway. So under sidesway frame analysis, we actually repeat the same process, 2A, 2B, 2C. Okay, in 2A, we calculate FEM due to external loading. In 3A, we also calculate FEM. But in this case, we need to assume FEM because the delta is unknown. The delta is unknown. So we will assume FEM due to delta prime, not delta. Okay, and step 2B equal to step 3B. So we need to calculate end moment, member end moment in table number 2, and we label as M prime. And after that, by using the moment, the end moment that we get from table number 1, we can calculate the restraining force R prime. So how the frame look like? Okay, how the frame look like? The frame is actually the frame subjected to R prime, not R, subjected to R prime. Okay, without any loading on member. Okay, on member. So this is the frame that we analyze in table number 2. Okay, so how we can understand this? It is actually, okay, start from this principle of superposition. Principle of superposition. So diagram A is actually the concept, the idea, the original frame, where in original, due to P, okay, the frame is tend to move horizontally. Okay, move horizontally means there is a sidesway. Okay, sidesway. The frame will move because it is not symmetry due to loading. It is not symmetry due to loading. If the frame is symmetry due to loading and due to geometry, that is no sidesway. But by looking at diagram A, due to P, we know that this is not symmetry due to loading. So by understanding that this is sidesway frame, and we can see that there is a W. So in diagram A, there are W and delta in one diagram. W and delta in one diagram. But we cannot analyze it directly because delta is unknown. Delta is unknown. W is known value. W is given. In the question, W will be given. For example, this is equal to 75 kilonewton per meter. Okay, P is given value. This is 100 kilonewton is given, but delta is not given. So when delta is not given, it means that we do not know the delta value and we don't want to know the delta value. So that is why we have to separate between W, between 75 and delta. We have W and delta. W is 75. And we have delta. So can we calculate FEM due to 75 and due to delta in one table? Of course cannot. Of course cannot. So we have to remove delta first. We have to remove delta first. So in order to have the ability to calculate FEM due to external loading only, what we should do is we should change the frame, okay, the original one, the frame to properly restrain. So how to make this as properly restrained is by putting an imaginary support or artificial support at C. We know that the frame is tend to move to right direction, so we have to put the support at C. So by having this pin support, there will be a restraining force, the reaction towards the support. Okay, what we want is the horizontal reaction. So this pin will bring the restraining force R, and with this R, the frame is called as is now properly restrained. Properly restrained. So when it is properly restrained, this frame is now non-sway frame. So this is now non-sway frame. Non-sway frame. It is now non-sway frame. Okay, it is now non-sway frame. So in this diagram, we can be able to calculate FEM due to 75 kilonewton per meter UDL along member BC. Means that in the table, when we can calculate FEM due to external load, means that we can distribute moment. Okay, distribute moment. So we can analyze table number 1, analyze member and moment in table number 1, okay, easily. Okay, as long as we know that what is actually the process inside the table. Okay, so from fixed end moment, we can have the member and moment, and after that we use the member and moment in the table to calculate the R value. So this is actually table number 1. This is table number 1. Okay, to complete the principle of superposition, we have to have another frame that is subjected only due to Sidesway frame. Okay, we have to have Sidesway frame only. No FEM due to external loading. We want frame which is only subjected to Sidesway. Okay, to Sidesway. So how to do this? Okay, just imagine like this. When we have the frame, the original frame, which has W 75 kilonewton per meter plus delta. So when we need to divide these two things, we have we actually divide. Okay, we have divided actually. Okay, under B we put 75. So 75 is here. 75. Okay, 75. Okay, 75 is here. Plus okay, delta. Okay, plus delta. So we have 75 plus delta in different diagram. Cannot be one diagram. In different diagram. The question is in one diagram, and in the solution, okay, table 1 and table 2, we have to differentiate. Okay, we have to divide into 2. Okay, we have one frame to analyze only 75 kilonewton per meter W, and we have to have another frame subjected to, okay, where it only has delta. Okay, delta. So this delta will produce the moment, the end moment. Okay, the member end moment in the frame. this delta will produce member and moment in the frame. But remember, we do not know the delta value. And the delta value here is actually the actual value that we cannot assume. We cannot assume this delta value. Okay, we cannot assume. So directly we cannot analyze this frame. Directly we cannot analyze this frame. So what we can do is we have to analyze it indirectly. We have to analyze it indirectly. So okay, by applying the principle of superposition, it is 75 plus delta. It is actually W plus. Okay, we separate. Okay, we separate between these things. Okay, it is 75. It is 75 plus 0. Plus 0. Because we need to separate it. And it is 0 plus W. Because we need to separate it. 75 plus 0 and 0 plus W. And in addition to that, we have negative R plus R to neutral back that at original frame at C there is no it is actually just the rigid joint without any support. Okay, so means that negative R which come from support, artificial support, pin support at C have to neutralize. Okay, we have to neutralize back. So it is the restraining force in diagram B in table 1 is in left direction. Left direction means we have to have neutralize this R by another R in right direction. So means that we have negative R plus R. We have negative R plus R. Okay, we have another one. We have negative R, okay, plus R. And this is equal to 0. Negative R plus R. Negative R plus R. This one is equal to 0. Okay, this is all about the principle of superposition. But remember, diagram C, we cannot calculate end moment directly. Okay, we cannot calculate the moment directly. What we can do is we have to analyze it indirectly by introducing another frame which is proportional with C. Okay, which is proportional with C. So I have drawn back diagram C here. Okay, C. In diagram C, it is Sidesway frame subjected to R, and due to R, there is delta. Okay, delta at two position, at position B and at position C. Okay, delta, and of course due to delta, because FEM we can calculate due to delta. So due to delta, there will be end moment. In C, we label as M. We label as M. This is the member and moment in diagram C. Okay, in diagram C, which occur due to delta Sidesway or due to R. Okay, we label as M. But we cannot calculate this value directly. So what we can do is we have to calculate or analyze another frame which is proportional to C. So we introduce now diagram D where it is the same diagram except the label. So all label, for example R, delta and M, we have to differentiate. We have to put prime. R become R prime. Delta become delta prime. M become M prime. So we do this, okay? We do this in diagram D, and this is actually indirect. Okay? We analyze diagram C indirectly. Okay, indirectly. So indirectly, this is the, okay, and this is actually imaginary frame where we can assume, because this is not the real one. This is not the real one, but C is the real one. So the real one, we cannot assume the delta. We cannot assume delta. We cannot assume FEM. So we can assume in another diagram. In another diagram called diagram D. So actually the table 2 or Sidesway frame that we analyze in the solution, in the moment distribution method solution for frame analysis, actually referring to D, not referring to C. It is referring to D. So in table number 2, we analyze Sidesway frame, which is subjected to R prime, and due to R prime there will be delta prime, and due to delta prime we can calculate FEM, and due to FEM we can have the member and moment, which we label as M prime. So by comparing these two, it is just like we do interpolation. Okay, let's look at together. Okay, what we want is actually M. M is what we want. Because from the equation previously, what we want is the final end moment, or the total end moment, considering both external loading and Sidesway. Okay, so it is the total value or final value, doesn't matter, both can be used. Okay, and it is M naught plus M plus, okay, M naught plus M. M naught is the end moment in table number 1, but M is not M prime. This is M. So what is M? How do we get M? So we get M from this. Okay, from this. Okay, how we get M? Okay, so by looking at the diagram. Okay, we have diagram. We have two diagrams, C and D. And remember, we don't need to calculate delta value, and we don't want to know the delta value. So in diagram C, we have R and M. Of course, actually, due to delta. And in diagram D, we have R prime, we have M prime, and this is due to delta prime. Remember, I said we don't need to know the delta value. So we don't need to know this. So what we know from these four? R, of course, we get R from step 3, R prime. R we get from step 2C. Okay, M is the unknown. Okay, R prime we can get from step 3C. M prime we can get from step 3B. Okay, so between these four, R, M, and then R prime and M prime, so it is just like, okay, we learn previously in school when we have two triangular. Okay, when we have, okay, let's say okay, to understand the concept of diagram C and D, which I said it is proportional. Okay, we introduce another frame which is proportional. Okay, it is just like we analyze two triangular. We have two triangular. It is just like this. Actually, this representing frame. Okay, actually, this is representing frame. So we have two triangular. We have two triangular. We have, for example, we have, okay, this is M, this is R. And another diagram, we have M prime, we have R prime. M prime and R prime. So by understanding this, okay, diagram, okay, R we get from table number 1, step 2A. We get from 2C. Step 2C. Okay, R prime we get from table step 3C. M prime we got from table step 3B. Okay, and M is the unknown. M is unknown. Okay, so when we have this, can we create a relationship relating all this? Of course we can. Of course we can. So what is the relationship? Okay, we can write like this. M R M prime R prime. So we rearrange back. It is equal to, we group R together as R divided by M prime times M prime. So it is R prime divided by R prime times M prime equal to M. So this is called as correction factor. R divided by R prime is called as correction factor. Correction factor. So this, okay, this M is equal to R over R prime times M prime. We substitute into the equation. Okay, into the equation which we get from principle of superposition. From principle of superposition, it is M total equal to M naught plus M. M naught we get from step 2B. Step 2B. Which is table number 1. So it is MT equal to M naught plus M. M naught plus M. So when we substitute, okay, we get, okay, we will get, okay, it is like this. It is M total equal to M naught plus M. So M naught plus R over R prime times M prime. So this will be the equation to calculate member and moment for the question. Okay, so this is the equation. Okay, so this is just about the concept of principle of superposition and how we derive, okay, the equation to get the final end moment. Okay, to get the final end moment. If we refer back to the summary of the procedure, okay, we have the same actually subsection procedure under 2B and 2C and 3B and 3C. Okay, the difference only to step number 2 is for table number 1. step number 3 is for table number 2. Okay, so okay, step number 2, there will be no problem. Okay, there will be no problem because FEM, we just can calculate easily. If it is subjected to W, we can calculate using WS squared over 12. Okay, if it is subjected to point load, okay, at the center, we can calculate using PL over 8. Okay, if it is triangular load, of course, there are formula to calculate FEM, which is given and in the question normally, and we can also refer to the list of table of formula that is given in the back cover of the textbook. Okay, so all this procedure start from procedure number 1 and then move to procedure number 2 and then move to procedure number 3. The most complicated part, which many students think that this is complicated, is actually under step 3A. Okay, where we need to assume FEM for one member and we have to calculate FEM for another member related to FEM that we assume. And actually, this is not the structural part in this topic. Okay, to calculate FEM in step 3A, it is actually the application of mathematics in moment distribution method. It is just like, okay, inside this step, what we need to do is we need to do interpolation. Okay, what we need to understand is the ratio concept, how to get ratio. Okay, how to create relationship. Okay, for a triangular, when we have angle, can we write relationship using cos theta and sin theta? So that is all actually mathematical application that we implement in order to solve for the member and moment in Sidesway frame analysis. This is not, as I always say, some of the solution step when analyzing structure is not structure. It is application. It is mathematical application that we need to apply in the solution in order to determine the, in this case, is the final end moment. So we will focus after this only step 3A. I will guide all of you how to actually understand about this 3A step. Okay, how to assume about the sign convention of FEM that we assume. Okay, and then how we can analyze it easily. Of course, in the textbook, okay, in the textbook there is a procedure stated. Okay, in analyzing this FEM due to Sidesway, but I will show to you that this is actually not as tough as you imagine. Okay, this is actually the simple step, the simple mathematical step, and if we want, if we actually want to understand, we can understand, and it is as simple as you cannot imagine. Okay, so actually, because this is online learning, so you have assessment also online. It is up to you whether you want to calculate the the end moment using table. Doesn't matter, because what is important is you understand. Okay, not how you analyze. Not okay. It is not necessary for you to calculate the end moment using calculator one by one as you normally do in final exam. Okay, that's not the objective. The objective is we want to know whether students has the ability to analyze fixed end moment, member end moment, using fixed end moment, using distribution factor, and how student analyze Sidesway frame, non-Sidesway frame, And lastly is the final end moment. That is the important. The goal is very, very important. So feel free to remove any bad expectation, okay, or just change your mind, think that this is not as tough as you imagine. Okay, this is actually the process that we repeat. This is the process that we repeat again and again. Okay, even though you have 10, you have done 10 questions, you have done 20 questions, you can realize that you have actually repeat the process again and again. Okay, it is a simple process. It is a simple process, and you need to repeat the process again and again. Except different question may have different length, may have different EI, may have different angle, different geometry, and it will give us different results. Okay, different result. But I want all students to understand that step 3A is not as tough as you imagine. Okay, because it is just application. It is just mathematical application inside structural analysis course. Okay, so in my next video, I will only focus, okay, on step 3A. Okay, step 3A. I want everyone to understand what is inside step 3A. Okay, how to assume FEM, how to find ratio. Okay, about step 3A. Before I will actually continue video to cover, okay, to cover test, not test, to cover assignment. Okay, assignment question. There will be 2 questions, 2 assignment question, 1 beam question and 1 frame question. So to be able to understand the question that will be given, okay, you have to understand all this principle. Okay, so I think that's all for this video. Inshallah, I will continue to explain about 3A step. Okay, 3A procedure. Hopefully it will help you to understand more about MDM, and inshallah we will meet again. Okay, inshallah. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Till we meet again.